have two complex numbers that are in mod arc form, and we want to multiply them by each other to get a new complex number. Okay, there's a method in which you could make it much easier for yourself. So let's say we want to times z1 by z2. Basically, what we would do is we would times both multiplications together. So we do r1 times r2, and then with the angles and the cos, we would simply add z1's argument and z2's argument together to form a new argument. So we have cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2, and simply that's basically it. Now I'm going to use this to prove something called the Moivre's theorem. So suppose we have z, and z equals r cos theta plus I sin theta. So if we were to work out z squared, which is the same as z times z, we would use this method. So we would get r1 times r2. In this case, r1 and r2 is the same thing, so we have r squared we basically have r squared times, using this method, cos theta 1 plus theta 2, and they're both the same, so we have cos theta plus theta plus I, using the same formula here, sin theta plus theta, and that simplified is r squared cos theta plus theta. Theta plus theta is the same as 2 theta, so we have cos 2 theta plus I sin, here again 2 theta, and that equals z squared. Now suppose we want to work out z cubed. Now if we were trying to work out z cubed, what we would do is, it's the same as saying z squared times z. So using this as an example to help us, we would then do r squared times r squared, this is z squared by the way, so we're doing this times this, so we get r squared times r bracket cos theta 1, so 2 theta plus the theta of the other one, which is just theta, plus I sin theta 1, which is 2 theta, plus what was the other one, which is just theta, to give us our new value. And if we were to simplify this, we would get r cubed 2 theta plus theta is 3 theta plus I sin, same here, 2 theta plus theta is also 3 theta. So we worked out z squared times z, which is essentially z cubed, and we got this. Well, if we were to use the Moivre's theorem, now the Moivre's theorem states the Moivre's theorem says that if z equals r cos theta plus I sin theta, then z to the power of n is the same as r to the power of n bracket cos n theta plus I sin n theta. And as you can see, we basically proved that by using what we know about timesing two complex numbers together. Like here we did z squared times z, which is essentially z cubed, and in the end we got r cubed cos 3 theta rn cos n theta plus I sin 3 theta, which is essentially the same as what we were expected to get using the Moivre's theorem. And this theorem, the Moivre's theorem, his theorem is true for all values, for all n values, for all real n values basically. Okay? So this would work for any n value.